So we'll see about multiplication of two 8-bit numbers using 8085 now. So we'll take an example first. The multiplicand we are having here is 6 and the multiplier is 3 here. And so what we are going to do is 6 into 3 in decimal system would be 18, but as we know in processor we use in the binary hexadecimal system, and the processor understands only the binary values. So equivalent of 6 is 0110 and equivalent of 3 is 0011. So we multiply those two using binary multiplication method. I'm sure you would be knowing that. So the partial products are 0110 and again multiply 1 into second bit into 0110, that will be 0110. Third bit into multiplicand would yield again 4 zeros, and fourth bit into multiplicand would yield 4 zeros again. So add the four partial products and the final answer would be 001 0010. If you're going to convert this binary value into decimal system, you will get 18. So as you can see here, multiplication is nothing but a repeated addition process. You add as many times as the multiplier value here is. As the multiplier value here is 3, you move 3, 2, 1, 0. That is 4 times you are adding the value. And the final answer here is 1, 2, 3, 4, 5, 6, 7 and an 8-bit number. So a 4-bit number into a 4-bit number would yield an 8-bit number, and if there is a carry, there is a 9th bit for carry. So in order to program this particular thing, you need a register to store the multiplicand value, a register to store the multiplier value, and this multiplier value needs to be stored in another register as count in order to determine how many partial products we need to find, and another register to store the product, and if there is a carry, that is the MSB bit of the product, a register to store that as well. So in 8085 we will see how to program this particular multiplication. We are clearing the D register for carry, that is the MSB bit of the product, and in HL you are loading the 16-bit address, that is nothing but in L50 will be loaded and in H41 will be loaded. Now move B, N, it will load the data from the address pointed to by the HL value, that is 4150, to the B register. In this case that would be the multiplier, and you are incrementing the H value, that is you are moving to the next address. H will now contain 4151 and you are getting the data value from 4151, that is which is pointed by HL now to the accumulator, which will be the multiplicand, and also you are copying the multiplicand into another register C, which serves as a count register to determine how many partial products we require. Now we are adding the accumulator and the B value once, so the result will be, in case of our example, it is 6 plus 3, so that is 9, and now you are adding it again, so 9 plus 3 would yield 12. Now there is no carry here, so this particular instruction is not executed. Now it moves to DCRC, that is part 2 of it, moves to part 2, that is DCRC here. So C value is 3, so that gets decremented to 2. Now 2 is not equal to 0, so it moves to part 1. So our answer was 12. So 12 plus 3 would be 15, and there is no carry once again. So move here, and the DCR value now is 2 minus 1 would be 1. So there is no 0 here again. So again move to part 1. 15 plus 3 would be 18 in decimal system, but in hexadecimal system it would be F, that is 15 is F in hexadecimal system. So F plus 3 would be 1 0 1 1 and 1 2, so it would be 1 2, and there is no carry once again, and so it moves to DCRC. So 1 minus 1 would be 0, so this particular instruction becomes false, that is there is no 0, so it comes out of the loop and it stores the accumulator value into the address location 4152. So what is the accumulator value? Yeah, the accumulator value is nothing but the product, and you are moving there, so that is being stored in the address location 4152. Now we are moving the D register value to accumulator. What does D register store? The D register stores the MSB bit of the product, that is in case if it is 4-bit and 4 bit and you get a 9-bit number. That is, the MSB bit has a carry. Then the ninth bit would stand for that carry. So you are storing that carry into accumulator, and from accumulator you are storing in a desired memory location, which is 4153H. And we have got the product and the MSB bit of the product, and now we need to do is halt the program. Now we will see, taking the same input, same example in our processor, we store the multiplier value 3 in 4150 and the multiplicand value in 4151, and we will see a step-by-step execution here. As you can see, the looping parts going on here, and once the loop becomes false, it comes out of the loop, and this particular 4 instructions are being performed. And this is a small loop jump condition where you check for carry or the MSB bit of the product, and program is terminated now. So we need to check the output in the address location 4152 and 4153. So when we move on to 4152, we see that it's 12. 12 is an hexadecimal system, and when you convert it to the decimal system, you will find that the answer is 18. And as there is no carry here, the 4153 will be 00. So that is about MSB bit as a product and multiple.